Hello guys, I am Vaishali Kikan and we are discussing chemistry. Today we are going to start our chapter 4, the effects of the chemical reaction. We are going to understand a lot of concepts and we are going to practice some sample problems here in this video. So let's start our discussion with the first topic, that is a chemical reaction. First of all, we are going to understand what is a chemical reaction. Chemical reaction is a process in which one or more than one substance change into one or more new substance. We now need to understand that there are some evidences that the chemical reaction has occurred. So whenever the chemical reaction has occurred, we will be having one of these things. First of all, we can have unexpected change in the color, like when the iron rust, its color change from grey to reddish brown. Then the energy is released or absorbed. So burning of butane will be radiating the thermal energy. So here the energy is released. The third evidence could be the gas is produced. So if you have a chemical reaction, then the gas might be produced, right? The next evidence could be the formation of a precipitate. Now what is a precipitate? Precipitate is the formation of a solid as a result of reaction of two solution, right? So more than two solution can also react to form a precipitate. So precipitate is a solid in the solution. So formation of the precipitate is another evidence of the formation of a or happening of a chemical reaction. So burning of butane will be converting the colorless gas of the butane to the blue flame. So here also you can see the changing in the color, and apart from that the radiation of the thermal energy, which is the energy released. So we can say burning of butane is a chemical reaction, right? So now coming to the atoms in the chemical reaction, how the atoms are changed in the chemical reaction, what happens to the various atoms when we have a compound which is undergoing the chemical reaction. First of all, we are going to understand about the catalyst. What is a catalyst? Catalyst is a substance that makes the chemical reaction faster. Whatever chemical reaction we have, catalyst is going to make it faster, right, without itself being consumed in the given reaction. Catalyst will not undergo any change in the given chemical reaction. Now coming to the law of conservation of mass. According to the law of conservation of mass, during the chemical reaction, the total mass of reactants will be equal to the total mass of the products, and thus I can now calculate what are the number of atoms that are undergoing the reaction and what are the atoms that are produced with the help of the law of conservation of mass. So here hydrogen peroxide H2O2 in the presence of MnO2 as a catalyst is producing water and oxygen. So H2O plus O2 is produced when the hydrogen peroxide is dissociated, right? So now coming to the describing of the chemical reaction. So we can have the word equation or the chemical equations to describe the chemical reactions. Now reactants would be on the left side of the arrow and the products would be on the right side of the arrow. What is the word equation? Here we have the name of reactants or products, and in the chemical equation we have the chemical formula of the reactants or the product. In the chemical equation we are going to denote the state of the reactants or the products as well, like solid, liquid or aqueous. We can have some specific condition required for the reaction to occur also, which is placed in the chemical equation. We are putting specific condition like temperature condition, pressure condition also in the chemical equation. We are going to put the ratio in which the chemicals react. So we are going to understand the ratio in which the chemicals react with the help of the coefficients as well. For example, the word equation is hydrogen peroxide in the presence of MnO2 catalyst is undergoing the formation of water and oxygen and the energy is released. In the chemical reaction, we can represent this as 2H2O2 aqueous in the presence of MnO2 as a catalyst gives 2H2O in the liquid plus O2 in the gas plus energy, right? So here you can see the 2 and 2 over here are the coefficients which are representing the amount of the reactants and the product. Coming to the balanced chemical reaction. In the balanced chemical reaction, the total number of atoms of each type is same on both sides of the equation. Now we are going to discuss two questions, and after these two questions I am going to tell you how to balance the chemical equation, the overall steps. We are going to understand these steps with the help of these two questions. First question states, write the balanced chemical equation for the reaction of sodium in oxygen to produce sodium oxide. So first of all we have to write the skeleton equation. Skeleton chemical equation for the reaction of sodium and oxygen to produce sodium oxide is Na plus O2 gives Na2O, right? Now in the step 2 we are going to count the number of atoms on either side of the arrow. So here if I talk about sodium, here the sodium atoms are 1 and here you can see we have 2 atoms of the sodium. So 1 atom on the left hand side, 2 atom of the sodium in the right hand side. If I talk about oxygen, oxygen here are 2. So here we have 2 oxygen atoms and here we have 1 oxygen atom. 2 oxygen atom on the left hand side and 1 oxygen atom on the right hand side. Now in the step 3, we are going to multiply by the appropriate coefficient until the atoms are balanced. Right, what I am going to do, I am going to multiply the product by 2. And I am going to multiply the sodium by 4. So here you can see in the left hand side the number of sodium atom is 4 now, and the right hand side also the number of sodium atoms are 4. In the left hand side the number of oxygen atoms are 2 and in the right hand side also the number of oxygen atoms are 2. So now in the step 4 we are going to write out the final chemical equation because the sodium and oxygen atoms are now balanced. So the final chemical equation will be 4Na plus O2 gives 2Na2O. Right, coming to the next question which states, write the balanced chemical equation for the reaction of copper in silver nitrate to produce copper 2 nitrate and silver. In the step 1, first of all we are going to write the skeleton chemical equation. So copper plus silver nitrate, so Cu plus AgNO3 gives CuNO3 2 plus Ag. That is my copper 2 nitrate and silver Ag. Now coming to the step 2, we have to count the number of atoms on either side of the arrow. So here first of all if I talk about copper, here we have copper, here we have 1 atom of the copper, here we have the copper ion, and for the copper ion also we have 1 atom of the copper ion. So 1 copper on the left hand side, 1 copper ion on the right hand side. So copper, I can say it's a balanced. Now if I talk about the silver here over here is a silver ion and 1 silver ion. Here also we have 1 silver. So 1 Ag positive in the left hand side and 1 Ag in the right hand side. Now if I talk about nitrate, so I am not going to talk about N and O3 as different atoms. I am going to talk about the NO3 together because here in the left hand side and the right hand side NO3 is taken as it is. So this is a polyatomic ion which is not undergoing the dissociation. So I am taking NO3 as it is. So NO3 in the left hand side we have the number of NO3 to be 1 and in the right hand side you can see we have 2 number of NO3. So NO3 is making this equation unbalanced. So what I am going to do, I am going to multiply with the appropriate coefficients until atoms are balanced. So copper was balanced, I am not going to put anything over here. So here we have 2 AgNO3 which is giving me CuNO3 2 plus 2 Ag. I am going to put 2 over here and 2 over here. So let's see what happens to the copper. Copper I have not changed. So here we had 1 copper atom. Here also we have 1 copper ion. So 1 copper and 1 copper ion. So copper in the left and right side are balanced. Now if I talk about silver, silver over here is 2 silver ions, right? 2 Ag positive. So 2 silver ions are, and here we have 2 Ag. Silver is also balanced. Now here if I see NO3, here we have 2 NO3 negative ions and here also we have 2 NO3 negative ions. So now all of them are balanced. I can write now step 4 which is the final chemical equation which is Cu plus 2 AgNO3 gives CuNO3 2 plus 2 Ag. Now coming to the various rules that we have used. Now coming to the summarizing the rules for the balancing of the chemical equation. First of all we have to start with the skeleton equation that includes only chemical formula without coefficient. You can see in all of the skeleton chemical equations we have not used any coefficient. We are just writing the chemical formula without any coefficient. Coming to the next step, we have to balance the atom on either side of the arrow by placing the appropriate coefficient in front of the chemical formula. We have used the number of atoms in the left hand side and the right hand side of the arrow, and we have found out what are the coefficient by which I can multiply the reactants and the products so as to balance the chemical equation. Right. The next step states leave the atom that appears more than once to end. First of all, I am going to start with the atoms which are occurring only once, and if some atom is occurring twice or more than twice in the given reactants and the product, so I am going to leave it to the end. Treat polyatomic ion as one unit provided that did not change during the chemical reaction. So here, like we had taken NO3 as a one unit, right? We have not taken nitrogen and oxygen separately. We have taken NO3 negative as a one unit because it was not undergoing any change during the chemical reaction. Check the final equation is balanced. At last we had to see the balanced chemical equation. Now coming to the next concept, which is a synthesis reaction. Synthesis reaction is a reaction where two reactants combine to make a larger or more complex product. Right, so here we can have two reactants A and B which are going to combine to form a larger or more complex product like AB. Now predicting product of the synthesis reaction will involve the shimmering flashes of the sparkle which are coming from the burning grains of metal like magnesium. So in the sparkler, if you see, the magnesium is combining with the oxygen to form the sparkles. We can have some other metals also which can combine with the oxygen. So reactants over here are magnesium and oxygen, based upon which we now are going to practice a question which states write a balanced chemical equation for the reaction of magnesium with oxygen. The step 1 states reactant identification. So what are the reactants? Magnesium and oxygen are reacting, so reactants are magnesium and O2 obviously. Oxygen is present in the gaseous form and the diatomic molecule. Step 2 states we have to find out the type of reaction. We all know the reaction of magnesium with oxygen. I already gave you the example. It's a combination synthesis reaction. So here we are going to put the type of reaction as A plus B gives AB, which is a synthesis reaction. So obviously, what were the reactants? Mg and O2. So Mg plus O2 gives MgXO4. We don't know what are the subscript X and Y over here, right? In the step 3, we are going to use the ionic charge. We know the ionic charge of magnesium, we know the ionic charge of oxygen, and with the help of ionic charge, I am going to find out the formula of the product, right? So magnesium has 2 plus charge, oxygen has 2 negative charge. So we can write it as Mg2O2, and these 2 and 2 get cancelled out and we are going to get MgO as the product. So skeleton equation would be Mg plus O2 gives MgO. Now this skeleton equation is now unbalanced, and now we can balance it with the help of these steps in the tutorial one. So you can use the steps we have used in balancing the chemical equation from the skeleton equation, and you can find out the final balanced equation as 2Mgs plus O2 in gaseous form gives 2MgO in solid state. Right, coming to the synthesis reaction of non-metals involving hydrogen. Now hydrogen is a special type of atom, right? So hydrogen is going to form the molecular compound, right? It is not going to form the ionic compound. So here, because here we are talking about hydrogen which is going to form the covalent bond, there is no ionic bond, so it is not having any ions. Still we are going to use the ionic charge of the hydrogen to find out what would be the product, right? So here you can see H2 in gaseous form plus Cl2 in gaseous form is going to produce HXCl. So hydrogen will be treated over here as a +1 charge atom and chlorine as a -1 charge atom, right? So if I put the charges over here and if I balance it and if I find out what is the subscript value X and Y, I am going to get the equation H2 gas plus Cl2 gas gives 2HCl gas. This is a balanced chemical equation involving hydrogen. Similarly, we can have the reaction of hydrogen with oxygen to form HXOY. So H2 in gaseous form plus O2 in gaseous form gives HXOY in the gaseous form. Hydrogen will be again having the +1 charge over here and the oxygen will be having -2 charge over here. Because I am combining hydrogen with the electronegative atom, it will be having +1 charge. So 2H2 in gaseous plus 2O2 in gaseous gives 2H2O in the gaseous form. This is the given reaction, and in this reaction energy is released and the water is also released. So this reaction tells me that this can be a source of green energy because hydrogen and oxygen are combining to form the water, which is not a pollutant, and energy is also released. But here one problem lies, that hydrogen is not present as it is. H2 is not present in the earth as H2. It is present in the form of compounds, and from the compounds, if I want to make H2 in the gaseous form, I have to spend energy, right? So I can say it could be a source of green energy when we can get the H2 in the gaseous form. Coming to the synthesis reaction of non-metals which are not including hydrogen, we can have the product which depends upon the reaction condition, and thus I can say predicting of the product would be difficult. Carbon in the solid state can react with O2 in the gaseous form to form CO2 in the gaseous form. Whereas if I have two carbon in the solid state which is reacting with the same oxygen to form carbon monoxide. So depending upon the amount of carbon, here we have one carbon atom, here we have two carbon atom. So when we have the excess of carbon, we are going to form the carbon monoxide, and here we are going to form the carbon dioxide. So it is difficult to predict what would be the product in these kind of reaction without knowing all of the reaction conditions. Coming to the synthesis reaction involving compounds. So when we have the two of the compounds which are reacting, right? So H2 is a compound, CO2 is a compound. So H2 in the liquid form, when reacts with CO2 in the gaseous form, it is going to form H2CO3, which is known as the carbonic acid. So H2O is coming in the form of rain, and CO2 is present in the atmosphere, in the air. So in the air, when rain happens, the carbonic acid is produced, which is detected using the bromomethyl blue, which is a acid base indicator. Acid base indicator is used to detect if there is an acid or not, right? Carbonic acid is an acid, right? And it is going to turn the solution of the bromothymol blue from blue to yellow, right? So bromothymol blue is turned from the blue color to the yellow color when carbonic acid is dropped into it. And carbonic acid is producing the acid rain. Acid rain is again a devastating effect which is produced for our environment. It is, what it is doing, it is dissolving the coral reefs. How? Because coral reefs are produced of CaCO3. Calcium carbonate is the main component of the coral reef. So when calcium carbonate is reacted with acid rain or the carbonic acid, the calcium carbonate will get dissolved and coral reef will crumble. So acid rain is going to impact the coral reef. Acid rain is making our oceans more acidic. Similarly, we can have sulfur trioxide. Sulfur trioxide is also present in air, which can also react with H2O, water coming from the rain, and it is forming the sulfuric acid. Again, sulfuric acid is making our rain acidic. So how sulfur trioxide is formed? By the combustion of fossil fuels. So we have to limit the combustion of the fossil fuels. Now combustion of the fossil fuels is giving us energy, so we have to limit our energy requirements. Now coming to the decomposition reaction. Here we have a larger or more complex reactant which is break down into two or more simpler products. Like if I have AB, it is going to break down into A and B. So AB going to form A plus B is a decomposition reaction. Now in the decomposition reaction, we require some initial energy to start the reaction, even though a larger amount of energy is produced after this reaction. Coming to the prediction of the product of decomposition reaction. How to predict the products? We can have simple ionic compound. So whenever I have simple ionic compounds, their elements are produced by decomposition. Like 2KCl in the liquid form, when the electricity is passed, 2K and Cl2 is formed. So potassium and Cl2 are the forming 2KCl. This is how we can have the element formation when the ionic compounds are decomposed. We can have the molecular or polyatomic ionic compound. Now predicting what would be the product is difficult, right? Like we have 2 KClO3, when the heat is applied, we have 2 KCl plus 3O2, right? We are not having here 2K plus Cl2 plus O2, right? Here we have 2 KCl formation. Now even only compounds can also be formed after decomposition. when I am undergoing the decomposition, I am not decomposing into the constituent elements. I am having the compounds which can further be decomposed. So here we have the CaCO3. CaCO3, when provided with heat, it is going to form CaO in the solid and CO2 in the gaseous form. So CaCO3 is lime. It is a key ingredient in cement. And now when the cement is formed, we are using the high temperature like 1400 degrees Celsius, which is present in the kilns. And in the kilns, we are undergoing the decomposition reaction of the lime. So this reaction is undergoing in the kilns, right? So kilns are a concern for us because they are consuming huge quantity of fossil fuels, and I already told you, when the fossil fuels are burnt, we are having the formation of SO3, which is producing the acid rain. CO2 produced here is a greenhouse gas that must also be avoided. So I hope you understood all of the concepts that I have discussed, and I hope you are going to meet me soon in the next class. Thank you so much.